lecture. Today we are going to see working of hydroelectric power plant. In this particular video we are going to discuss about its construction, working, advantages, disadvantages and site selection for hydroelectric power plant. Basically power plants are used for generation of electricity. So main objective of this total arrangement is to generate an electricity. Whereas the name of this particular plant is a hydroelectric. This has formed by two words. First word is called as hydro and another word is called as electric. Okay, so hydro word taken from an hydraulic, whereas electric word taken from an electric energy. So in this particular power plant, the hydraulic energy is converted into electrical energy. What's meant by hydraulic energy? Hydraulic energy is energy which is stored in the water, or energy present in the water is called as hydraulic energy. Whereas electrical energy is a flow of electron. So here we are going to convert a hydraulic energy into electrical energy by using this particular arrangement. So basically there are 2-3 major important parts in this particular power plant. So first part is a dam. This is important part, dam. This is another part, that's what called as turbine house, and third part is penstock. These are three important part of hydroelectric power. What is a dam? Dam is required to store water at higher height. So this dam will be at high height, whereas a turbine house will be at lower height. If you see actual example of height of dam from the turbine, it may be in a kilometers, like 1 kilometer, etc. And this dam is built at higher height and stores the water. Whereas turbine house is on lower side, and dam and turbine is connected by using a pipeline. This is a pipeline which is used for connecting dam and turbine house. This pipe, technical name is what? A penstock. The penstock is a pipe which carries the water. If you see an actual diameter of penstock, the diameter of penstock is 2 meter to 3 meter. So you can imagine that a 3 meter means it's almost 10 feet. So diameter of this particular pipeline will be a 10 feet and water will be carried forward. At the end of this particular pipeline, you will observe that there is one wall for opening and closing of the flow of the water to the turbine. This is wall, and this particular part is called as nozzle. You know that the nozzle is a converging area pipe where the pressure energy get converted into kinetic energy. So at the entry of the nozzle there will be high pressure energy, whereas exit of the nozzle will have a kinetic energy or a high velocity jet of water. Then this is particular device is called as a turbine. So you should know what is meant by turbine. Turbine is a device which will give you mechanical energy as an output. So mechanical energy means any solid part which is rotating or reciprocating or oscillating, we say it has a mechanical energy. If you see around us, the 95% of the time we see rotary mechanical energy. For example, the fan is rotating, so it will have rotary mechanical energy. The rear wheel of your bicycle, it's rotating, so it will have rotary energy. So rotary mechanical energy is very useful in many of the application. This turbine will have turbine blade. So this is called as a turbine blade, or another name is also called as a bucket, which is connected to rotor. This is a rotor, white color what you are observing, that's rotor. So this turbine blade are firmly connected to rotor, and at the center of rotor we are having the turbine shaft. So we are going to take a mechanical energy output from this particular turbine shaft. So this turbine shaft will be rotating, and this energy will be useful for generating an electric power. After the shaft we will be having the electrical generator. The function of electrical generator is to convert mechanical energy into electrical energy. Here we are not shown the electrical generator, but you have to assume that this shaft is connected to electrical generator. Electrical generator will take mechanical energy from this and will give you output as a electrical energy. So in order to avoid a confusion, specifically I have not shown the electrical generator. Okay, there is one more part, that's what called as the surge tank. The function of surge tank we'll see and later on. So we have seen what is dam, what is penstock, what is wall, what is nozzle, what is turbine. Now let's go for understanding working of this particular, how it will work. So assume that currently this particular power plant is not working and we have to start generating electricity. For starting electricity generation, what we have to do is this wall should make it open. Open means what? When we are going to open this wall, the flow of the water will start. So I'll show you animation related to this one. So I have removed the wall from this one, means the wall is open now, and then the flow of the water will start. So you can see that the flow of the water has started. Jet of water is coming outside and it strikes on the bucket of the turbine. When it strikes on the bucket of the turbine, it will give force here, and because of force the bucket starts rotating, or blade start rotating. Blade is connected to rotor, so rotor will start rotating. As rotor start rotating, shaft also start rotating. You can observe here if you check that the water is coming from this dam, and finally we are getting here mechanical energy as an output. Okay, so here there are number of conversion of energy. So you can see that the conversion here I have shown you chart. Potential energy will convert into kinetic energy, then kinetic energy into mechanical energy, mechanical energy into electrical energy. So potential energy into kinetic energy, it will convert in the pipeline and the nozzle. You can see here that before dam we are having a potential energy. What is potential energy? Potential energy is energy because of its position. So as I told you, dam is at higher height, and as it is at higher height, it will have a high potential energy. This water is flowing, the water will come outside. So here we are having high velocity jet of water. So as it is having a high velocity, I can say it has a high kinetic energy. This kinetic energy ultimately converted into rotary motion of shaft, and that's why I can say that it has a rotary mechanical energy. And then this turbine is connected to the generator. I have shown you symbolically, and after generator we will get finally electrical energy. So there are conversions of potential energy into kinetic energy, kinetic energy into mechanical energy, mechanical energy into electrical energy. Okay, so these are the converting part. Now after this, when we have to stop this particular turbine, what we have to do, the wall which was present here, that we have to make it close. So after closing this particular wall, what happens, let's check. When we are going to close it, so let's consider that I have put a wall here, means now close, and the flow of the water has also stopped. When we suddenly close this particular wall, the water which is rushing through a 10-foot diameter pipe, that will give a very high pressure on this particular area. Inside a pipeline we are having a water, and that water will try to rush forward, but I have closed this wall, and as I have closed this wall, the water cannot move forward. As water is not moving forward, in this area of the pipeline very high pressure is generated. Because of this very high pressure, there is a chances of bursting of this particular pipeline. In order to avoid this bursting of pipeline, what we have provided is the surge tank. What is surge tank? Surge tank is a simple tank which is connected to penstock. When pressure tries to go above, the water will get a space and it will enter into what? This particular surge tank like this. Because the water can enter here, the high pressure in this particular zone will be reduced and the bursting of the pipeline will be avoided. At the same time, water hammer effect also can be avoided. We can see that by the animation, water is filling up, and that's why the pressure will be get reduced, and as pressure get reduced, water hammer can be avoided, or bursting of pipeline can also be avoided. Okay, so now